Wait, is
Okay,
this
we're gonna.
5B?
This is 3.5b. Yeah, we'll call it B. We're going to talk about something we've kind of brought the topic up just very what's the word? Briefly, indiscreetly. Okay, I haven't really talked about it a whole lot, but I've mentioned it from time to time, and that's talking about proofs. Do you ever hear me talk about a proof?
Yes.
You hate them already? You don't even know what they are. Okay.
Because
I don't know
they're
what the word
math.
that transitive property.
Is that right? Yeah, it's. I mean, I'll just say it right now. When you talk to people that have already had geometry, and a lot of people will say, "Ooh, geometry," and then I hate it, and then the next thing out of their mouth is proofs. Okay, but not everybody feels like that. I remember one year I had a class. One year out of all the years I've taught, one year I had a class, and they loved it. And in fact, at the end of the year, I had them fill out like an evaluation for the class. You know, what you liked, what you didn't like, what you would want changed, and all that kind of stuff. And there's about 4 or 5 of these girls, and they were into it. They loved doing proofs, and they wrote on there, "We love geometry and we love proofs." And it's funny. I still keep in touch with some of them on Facebook even today, and every once in a while they'll mention that. Yeah, remember proofs in geometry? We love doing those things.
Except I don't have Facebook.
Oh well, that's okay.
I like.
You don't have to. It's not a law that you have to have a Facebook. Okay, let's do this. What I'm going to do, listen now. Come on. What I'm going to do is we're going to start off, I'm just going to basically show you what a proof is, and we're just going to jump right into it. You may not have a complete 100% understanding of it when we first do it. All right, I'll warn you right now. But the more we do them, the better and better you're going to get at them, the more you'll start understanding. Okay, so when we do it at first, you're going to look at it and like, oh my goodness, what did we just do? But then you do 2, 3, 4, 5 more, okay, together in class, and you're like, okay, now I kind of see what he's getting at. Now I kind of see what we're trying to do. And that will eventually happen. Right now, at the beginning, it's so different, all right? It doesn't seem like it's math at all. Okay, but it's something that we... Yeah, it is. It's kind of interesting. It's I'm not really a big puzzle person. I'm in the middle of talking.
No, it's section.
I'm not... Seems like every time I open my mouth, 4 other people start talking. It should be the other way around. When I open my mouth, you should close your mouths, right? All right. Like I was saying, now I forget what I was saying because what was I gonna say? Oh, it doesn't seem. Yeah, it doesn't seem like math. It's a little bit different. So just bear with us, okay? This is what we have. We have 2 lines right here. What they'll do, for the most part, they'll give you a picture. Right, and then they're going to give you, I'll tell you what, let's fill in the picture. In the other class, I did the other stuff first. Let's do this first. Let's call this angle 1. Let's call this one angle 3, and this one angle 2. All right, so they give you a picture, and they tell you some stuff that's true about this. Now, do I know that 1 and 3 are equal to each other? Why not? I thought they're corresponding angles. I thought corresponding angles were equal. That's right. It's not parallel. Exactly right. Okay. This is not parallel right here. I don't know it's parallel. It looks like it is, doesn't it? All right. But I don't know because there's no arrows right there. So I can't say anything about that. And that's what we're actually going to try to do. We're going to try to prove that those 2 lines are parallel. So L and M, we want to prove that they're parallel to each other. So what they do is they usually give you something. And that's always nice. And it seems like the more they give you, the better it is. All right, so they're going to give you that angle 1 equals angle 2. Now, I wouldn't have known that. Now, they are alternate exterior angles, but just because they're alternate exterior angles, does that automatically mean they're equal to each other? No. If the lines are parallel, but we don't know the lines are parallel. So the only way that I know that is because they told me. All right, so they told me that angle 1 was equal to angle 2. First thing I'm going to do, especially with the given, is I'm going to mark it on my picture. All right, it's a habit you should get into. If they give you the given stuff, I go to my picture and I mark it, if I can, on my picture. What we're trying to do is we are trying to prove something. We are trying to prove that line L is parallel to line M. And in fact, we're really trying to say, and I know what you're going to say, Chris, but hang on for that just a second. What we're trying to do is we're trying to prove that if these alternate exterior angles are equal, then what? The lines are parallel. That kind of sounds like a theorem we've talked about, doesn't it? Okay, it's the converse of that alternate exterior angle theorem. All right, so what we're trying to do is we're actually trying to prove the theorem. So what we can't do, we cannot use the theorem itself to prove itself. We can't say, well, if 1 and 2 are equal, the lines are parallel because alternate exterior angles says it is, right? Well, we're trying to prove that theorem in the first place. You ever take an English class and they talk about defining things, and they say you can't define a word with the same word? You can't use the word in the definition. Is that what they say? Yeah, that's probably a better way to say it. Right, so you can't use that exact word to define itself, can you?
No.
It's kind of like this. You can't use you can't use the theorem itself to prove itself. So we are actually trying to prove a theorem. What are we trying to prove? We're trying to prove the theorem that says if the alternate exterior angles are equal, then what? Then the lines are parallel. Then the lines are parallel. This is what we're trying to prove. We're actually trying to prove this theorem right there. All right, so if the alternate exterior angles are equal or congruent, then the lines are parallel. That's what we're trying to prove. I can't use that theorem itself to prove itself, just like a definition. You can't use a word to define itself. You with me? Yes.
So can we use a similar theorem?
We can use something that we used before this, absolutely. Okay, I think you see it already, don't you? Yep. Okay, just hang on for a second and let's continue with this. All right? But you can use something that was before this. Remember, this was a theorem. We learned a postulate before this, didn't we? Do you have to prove a postulate? No. Postulates are just accepted facts, right? You can prove a theorem, but you don't prove postulates. Postulates are just accepted. So let's do this first. Let's set this thing up. There's a way we do this in high school. This is kind of more of a high school thing. It's not usually something that we do in upper level math, but we do a thing called a two-column proof. So I'm going to have a line going across and a line going up and down, and I got two columns right there. That's why they call it a two-column proof. All right, not much of a stretch, is it? All right, so on the left side, what we do is we call this side our statements. And on the other side, we have to back up our statements, and we have to give a, what do you think? A reason. That's right. So we call these reasons over here. And so that's how you should set up every single proof. Okay, two columns. The left column is statements, and the right column is reasons. So what we want to do is we want to list some things in order to show. We want to eventually list a few steps until we get L being parallel to M. Now we can't say it right now because remember, we're trying to prove this theorem to begin with. All right, so we have to pretend that we don't even know that this is true yet. Does that make sense? Because we have to prove it. So, but there are some things that we learned earlier that we can use to prove it. So, what do you think? We know that 1 and 2 are equal to each other. What else do you think you could say about angle 2? What do you think, Allie? Saying, that's right, very good. And I like what you said. It's equal to 3 because she gave a reason right away, didn't she? She said it's equal to 3 because they're vertical angles. All right, so watch what we have. Alyssa, do you see it?
Oh,
Go ahead.
well, yeah.
Go ahead.
Oh, if 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3.
That's right. See, look, 1's equal to 2. Why was 1 equal to 2?
Because it's given.
It's given. Right, they told us, right? And we write given. So let's start our, actually, this is what I like to do. I like to think through our proof first before we write anything down. So let's do that first. We said that 1's equal to 2 because they told us, right? It's given. That's what we write. And then what can you conclude from there? 2's equal to 3. What reason do we say? Vertical angles are congruent, right, or equal. Now look what we have. We got 1 is equal to 2. 2 is equal to 3. Guess what? 1's equal to 3. What's the relationship between 1 and 3? They're corresponding angles, aren't they? Now, we already know that, don't we? We don't have to prove that. We know if the corresponding angles are equal to each other, guess what? The lines are parallel. Guess what we just did? We proved that the lines are parallel with that information that was given. Wasn't that cool? It's kind of like a little puzzle, isn't it? I'm not big into puzzles myself, but stuff like this, it's kind of cool to figure it out and see, you know, where the thing's going. And that's what we're doing right here. Did you follow? Now look what I did. That whole mindset of writing down the given, looking to see what else is true about this picture, and all that kind of stuff. That's what you want to go through on every single proof. You want to think that way. You want to write the angles equal to each other. You want to think of the reasons to back it up. Do all that stuff in your head before you even start writing down anything in your 2 columns. Does that make sense? So now you at least know where you're going to go. All right, it's like looking at a map before you start on a trip. You don't start driving on your trip, going down the road before you're like, you know what I should do? I should figure out where I'm going, right? You don't do that, do you? I don't know. You probably don't drive on trips too much, do you? Or at least are the navigators. You just go along for the ride. But once you start driving, that's what you'll do, right? Of course, nowadays, you don't look at a map anymore. Yeah, you stick it in your GPS, you know, and there you go. But with me, even on GPS, if I'm going somewhere where I haven't been before, man, I'm looking at it on my GPS. I'm looking at it on Google Maps. I'm looking at it on, you know, on Google Earth. I'm knowing where I'm going before I get in the car and I start heading there. Would you agree? It's the same thing here. I want to know where I'm going before I actually start doing the writing. Okay. So what's the first thing we said? That's it. Angle 1 equals angle 2. A lot of times we can number these steps if you want to. You don't have to number them, but we'll number it. Okay, so step 1, we said 1's equal to 2. Give me a reason. Why was 1 equal to 2? It was given. That's right. That's the only way that I knew that those 2 angles were equal to each other, because they told me. They have to tell you some things. All right? Now, what did we do there? We went 1 equals 2. Then we went what? 2 equals 3. So I said angle 2 equals angle 3. And what was the reason for that? That's good. It's perfect. Vertical angles are equal or congruent. That's supposed to be an S right there. All right? And you can shorthand it. That's fine. That's an actual theorem. Okay? I don't know what number it is. I don't care what number it is. But it's a theorem that says vertical angles are congruent. You can use theorems as reasons, yeah, because we've already discussed this. We've already talked about why it's true. But yeah, you can, I mean, you can prove this as well, but
So we just
We-
can't use them as proofs.
well, if you're trying to prove the theorem itself, you can't use it. So if I had like 2 lines and I said, okay, prove that 1's equal to 2, I can't just say, oh, 1's equal to 2 because they're vertical angles. No, I'm trying to prove that theorem to begin with. All right? Does that make any sense? Okay. So we're not going to get into that one right now. Maybe later we'll talk about that. Let's keep going. So 1's equal to 2, 2's equal to 3. Now, you guys said something that was good. 1 equals 2, 2 equals 3, so what? 1 equals 3. Now, there's a reason for that. We can say that 1 equals 3, because if you look at this, look, it just follows real nice, doesn't it? 1 equals 2, 2 equals 3, so 1 equals 3. There's a reason for that you probably haven't heard. You know how we skipped chapter 2? There's a few little things in chapter 2 that we have to cover every once in a while because we skipped it. And that's this thing right here. It's called the transitive property. And you probably learned this back in Algebra 1, to tell you the truth. It's called the transitive property. It basically said this. It said if A equals B, I don't know, did you remember doing this in algebra? Yeah. If A equals B and B equals C, then what do you think? A equals C. Does it make sense? Okay, it's kind of a no-brainer. It's kind of like a, you know, it's logical, you know, you think, well, it's common sense, you know, that kind of thing. But it's also another property, if you want to call it. Watch. If A equals B, that means A and B are the exact same thing, aren't they? Watch what I could do. I could, instead of saying B equals C, what could I say? I could say A equals C, couldn't I? That's basically substitution. Do you remember doing substitution in algebra? Okay? So you could look at this as substitution. So our reasons could be 2 things. It could be transitive property, or it could be what? Substitution. Either one of those is a reason why 1 is equal to 3. I like transitive. It's kind of slick. If A equals B, B equals C. You could keep on going, couldn't you? If A equals B, B equals C, C equals D, then what? A equals D. All right? If it keeps on going. So let's call it the transitive. Whoops. Wow. Transitive property. Thank you. All right? Transitive property. Everybody good? So now, if 1's equal to 3, what's the relationship between those two? Between the angles. They're corresponding angles, aren't they? And they're congruent. So now I can say that L is parallel to M. Why? Because, that's right, because the corresponding angles are what? Congruent. Technically, it's the converse, right, of the corresponding angle theorem, but we're okay just saying corresponding angles are congruent. I'm good with that. Make sense? That's our first proof. How about that? Wasn't that exciting? All right. I'm making you nervous.